Okay, guys, so here are the phase 6 notes. So the limit of a function exists if and only if both the left hand and right hand limits exist and are equal. Okay, so let me just, so when we're talking about, okay, let me just show you this that I wrote down. So we've talked about left hand limits and right hand limits. Sometimes the limit from the left and the limit from the right are going to match. And in that case, we just say that the limit, just the limit itself, is whatever that matching number is. So here's an example. So if the limit, and guys, pay attention to the words that I'm using, the way that I'm saying, the way that I'm reading this. The next phase we'll have practice, like making sure that you guys just can read this correctly, like translate this into words and translate words into this. Okay, so that'll be the next phase. It'll be super easy, but I just want to make sure we've got this notation down. So if the limit as x approaches 5 from the left of f of x equals 7, and the limit as x approaches 5 from the right of f of x equals 7, then, and this is the new thing, then the limit as x approaches 5 of f of x equals 7. So if the left hand and right hand limits are the same, then we say that the limit period is that number. Okay, but the left and right hand limits have to be the same in order for this to happen. Now sometimes they're not the same. Let's look at that case. If the limit as x approaches 3 from the left of f of x equals 10, for example, and the limit as x approaches 3 from the right of f of x equals -2, for example, just an example, then the limit itself, the limit as x approaches 3, period, of f of x does not exist. Okay, so if the left hand and right hand limits are not matching, then the limit itself does not exist. Okay, so let's do some examples here with using this graph. So in this column, we're going to do the left hand limit. LH limit stands for left hand limit. And then we'll do the right hand limit, and then we'll say what the limit is, period. And that would, the limit itself, period, means like from left and right simultaneously. Okay, so the left hand limit at -8. All right, so here I've got my graph. Here's -8. Okay, so the left hand limit. So from the left, so that's where -8 hits the graph. From the left, I'm looking at these points. So the left hand limit, the y's, what's the number that the y's are getting closer and closer to is -6. Okay, now the right hand limit at the same number, so approaching -8 from the right hand side, the y's are again approaching -6. So what is the limit at -8? It is -6. All right, because these are matching. Now let's do the left hand limit at -2 and the right hand limit at -2. Okay, so here's -2. Right, there's -2. Okay, so I'm on the graph for points with x values to the left of -2 and approaching. So the y's are approaching 3. And now the right hand limit at -2. So I'm on, like, to the right of -2. So these points. Okay, so those y values are shooting up to infinity. Let me try. Oh, that wasn't bad. Infinity. So what about the limit at -2? It does not exist because these have to match. All right, now let's do 6. All right, so here's where 6 is. All right, so points that have x's to the left of 6 and are approaching 6. We're looking at this sequence of points. The y's are approaching 2. Okay, now the right hand limit. So I'm using these points to the right. The y's are approaching 5. Okay, so again, the limit at 6 does not exist. All right, now 10, then we just got one more thing. All right, so here's 10. Okay, points to the left, points with x's to the left of 10, and approaching, the y's are getting closer to 0. Now I want to be to the right of 10 for my inputs and getting closer to 10 for my inputs, and the y's are 0. So that means that the limit at 10 is 0. Okay, now we're going to do these. So find the following limits using your calculator. Please show your table of values for the left and right hand limits. Okay, so here the limit as x approaches 3 from the right of this function. And guys, very often you'll see that I like to do parentheses around it so that it looks like, this is almost an input. This is like the input of the limit. Yeah, I really like the parentheses. Whenever I type it out myself or write it out myself, I put parentheses. All right, so we need a table of values. Okay, so I got to be to the right of 3. So numbers to the right of 3. All right, so here's 3, there's 2, and there's 4. Okay, so numbers to the right of 3 and very close would be like 3.1 and getting closer. And then to the left would be like, 2.9. So if I'm to the right, I'm going to do 3.1, 3.01, 3.001. All right, and then for the ones to the left, 2.9. All right, let me go grab a calculator, sorry. Okay, now in the calculator, I'm going to type this fraction, so I want parentheses around the top, x squared minus 9, close them, divided by parentheses around the bottom. Remember, I don't want to use that fraction bar thing because then my table will give me fractions, and I want to, when I'm thinking about a limit, I want to be able to see decimals. All right, and then I just go to table set, make sure it's on ask, it is. Then I go to the table, 3.1, 3.01, 3.001. Okay. So I see negative 1.564, negative 1.506, negative 1.501. It looks like negative 1.5 is what we're approaching. Let me try again. 3.0001. Yeah. Okay, it looks right like it's at negative 1.5, but remember, if you put the cursor on it, this is the actual number, and it is true, it's getting closer to negative 1.5. So, so as x is approaching 3 from the right, y is approaching negative 1.5. So the answer here is negative 1.5. Now we'll do, the one from the left, 2.9, 2.99, 2.999, 2.9999. Right, and again, that negative 1.5 is actually this. All right, so when I'm doing these ones, 2.9, negative 1.439, negative 1.494, so again, we've got our y's approaching negative 1.5. 3 from the left. No. X. As x approaches 3 from the left, y approaches negative 1.5. So the answer again is negative 1.5. So that means that the limit as x approaches 3 of this function is negative 1.5. And the reason is that both the limit from the right is negative 1.5 and the limit from the left is negative 1.5. Okay, guys, I'll talk to you later.